Good afternoon, everybody. I'm Al, founder and CEO of ID.
I'm Dennis, the CISO of ID, and today we're gonna show you how to hack the world's most popular MFA.
And how to prevent it from happening to you. But before we do that, we want to tell you a bit more about MFA in the UK. So, did you know that 95% of UK businesses use MFA? It's pretty impressive, isn't it?
So then, why were 58% of UK businesses breached? And even on that, many of them were breached more than once.
Unbelievable. Hold on a second, Dennis. I don't get this. So, there is a Microsoft study that says MFA reduces the risk of compromise by 99.2%. So how is this possible?
Well, I think you need to start paying attention to the small prints.
Okay.
Yeah, so this survey was actually based on accounts with non-credential leaks.
I see. So the credentials is already leaked, and so MFA, I guess what Microsoft is saying, MFA would prevent password-based attacks.
Absolutely. So unfortunately, the inconvenient truth is that MFA cannot prevent more than that. It can only prevent attacks such as credential stuffing, brute force, or password spraying attack, and that's what it can do.
So you mean like, the first generation MFA, that's what it can do, okay?
That's correct.
So let's just maybe summarize. So 95% of UK businesses use MFA. Probably all of them use first generation MFA. 58% were breached last year. Some of them were breached multiple times. So how is this possible, Dennis? How is this possible? I don't get it.
Yeah, so it's possible. There are many ways that MFA can be compromised, even if you are using what they said MFA.
So what you're saying, bottom line, MFA can be bypassed.
Definitely.
Okay. How is that possible?
So I'll just give you 3 tips on how that can happen.
Okay.
So the number one being that all MFAs that use OTP can be compromised via a credential phishing attack.
Okay.
And the second one is all MFAs based on push can be compromised using prompt bombing, or what some people know as MFA fatigue.
Okay.
And
wow.
Yep. And my favorite, adversary in the middle attack, can actually be used to bypass all traditional MFAs.
Wow. Okay. So then let us show the people watching how we can bypass these first generation MFAs that require 2 devices. Dennis, why don't you take it over and we can show them how it's done?
Yep. Action they say speak louder than words, so let's do it.
I like it.
So this is Infosecurity, and I will start it. So this is what an attacker will usually use to bypass all the MFAs. And just to make it clear, we are not picking on Microsoft, because as you can see here, almost all the other service providers that relies on traditional MFAs can as well be compromised using this adversary in the middle attack.
So you're talking about OTP whether delivered via an app or SMS, you're talking about push, talking about QR, all of these MFAs, these first generation MFAs can be bypassed.
That's correct.
Okay.
So here, this is an example of a typical phishing email that a user would get. And unknowingly, they will click on it to access their Microsoft Office or Microsoft application. And clicking on it, as you can see, would take me directly to Microsoft to log in, as I would with my credentials. And looking here, you will see this is the phishing URL. It's not really the normal Microsoft login. And here now, I will copy my credentials and enter the username. Next, they ask for my password. And as you can see, I'm using a complex password as per password best practices for those that believe in it. So here, because I have entered my credentials,
correct,
and my password, then I'll receive a push from Microsoft.
So now you're receiving a push on your Microsoft Authenticator.
Yes.
Okay.
To log in.
Okay.
So then I will enter the number, so the number matching. And
okay, so not only are you receiving a push, you're now number matching on top.
That's correct.
And did you just get logged in?
So let's see what happens. So here, I want to do it again, just to make sure that everyone is following, that it was not so fast for people.
Okay, please, yeah.
Yeah, so I'll enter my email. Then the next, I'll enter the password. And then I'll click on sign in. And as before, I'll receive a push on my phone.
Okay.
To log in. And I will type in the number, which is 80. And what that happen is, it will log me in to my Microsoft Office account.
Okay.
And what happens on the background is actually that after logging me in, the attacker will actually redirect me to the Microsoft real page so that I'll not even know what has happened.
Wow. So it switched from the fake domain to now the real Microsoft domain.
That's correct.
Wow. Okay.
Then to see what just happened now, what an attacker has, we now go back to the Evil Genius console. So looking here, you will see all authorization tokens intercepted. So this means that all I have been doing, that the attacker have been monitoring it, and now they have stolen my authenticated social cookie.
And it looks like they also captured your email and your 20-character alphanumeric complex password.
Yes. So let me make it more open so that you see everything that they have captured. So if you see here now, the last session we just did now is session number 50.
Okay.
And you can see the time that we did it here.
Yeah.
And when I enter that session, sessions 50, it will open the complete details of what they've captured.
Okay.
So here you will see my email address. They captured it. Here you will see the 20 characters alphanumeric complex password here. They captured it. Here is just so that you know the fake URL.
The phishing URL.
The phishing URL. And down here, this is the crown jewel. So this is the authenticated cookie that they can use to log into my account without needing my password or my push or OTP.
Wow. So what would you do with this authentication token, Dennis?
So what an attacker would do is to copy this.
Okay.
Then they will go to a browser, for example, in this case, I'm going to use Chrome. They'll come to a login page like this. But instead of typing my password and my email and my password to log in, you just go here, edit, remove the cookie, import the cookie, and when you save it, you just have to refresh.
Wow.
And I'm in.
Wow. So that was, let me just summarize this. You had a complex 20-character alphanumeric password. You had push-based MFA with number matching. And even then, this adversary in the middle attack bypassed that security and logged you in. We are able to steal the authentication token, you know, the username and the password now, and you were able to get access to that account. So
yes, as I said earlier on, Al, with adversary and middle attack, you can use it to bypass all traditional MFA. And that's
all first generation MFA. Okay.
Yes, and that's what we just did.
Wow. Okay. Thank you, Dennis. Let us then continue with our presentation. I'm gonna hit play again. So I guess this means that whoever wrote the sentence at Microsoft is clearly clueless, because you just bypassed Microsoft Authenticator with a complex password, with push, with number matching. So I have no idea how somebody at Microsoft could write this, but maybe that is Satya Nadella's problem, not ours. So let's do this then. Let's not just leave people in suspense and scare them, but let's also provide a solution. So the good news is you can prevent MFA bypass today without using any kind of artificial intelligence, machine learning. And Dennis, why don't you tell us how that is possible?
Yeah, let's do it. So, as I did earlier on, I will also give you 3 easy ways you can use to prevent your MFA being bypassed.
Okay.
So, number 1 is same device MFA. If you watch what I just did, the demo we did currently, you find out that I have to use another device as my MFA to be able to log in to Microsoft. And the fundamental issue here is that you are not able to say whether my phone is near to my computer where I was logging in.
Excellent point. Yeah.
Yeah. So if you can be able to make the same consumption device as the authenticator, then you eliminate that vector.
Same device MFA. Okay, that's number 1.
Yeah. Then the second one is you need to bind the identity of the user to the device. Doing that, that's the only way you can be sure that that trusted credential is being used to access the service from that trusted device.
Okay, so that makes sense. Bind the identity to the device.
Yeah, and finally, but the most important is transitive trust. So transitive trust ensures that only the user can authorize a transaction on a trusted service with a trusted device and under the user's total control. So you need to get this very clear. So that you have a trusted credential is not enough. You also need to be sure that that trusted credential can only be used on a trusted service so that it cannot be stolen.
Okay.
And that trusted service can only be accessed from a trusted device. And that's not enough yet. You also need to be sure that the user accessing that trusted service on that trusted device is in control when that access is happening.
So the user needs to be in control of the trusted device, not just having the trusted device is enough. Wow, so trusted service, trusted device under the user's total control.
That's
Wow,
correct.
okay. Transitive trust is clearly extremely important. So is binding the identity to the device, and so is same device MFA. But maybe this helps people visualize it. What do these three things do? Or more importantly, what happens if you don't have them? This is what happens. As you can see in this diagram, if you don't have these capabilities, you have an infinite attack vector, meaning anybody that can steal your credentials can access your endpoint and your network and your data and your application and your infrastructure. So what these three things do, same device MFA, binding the identity to the device, and transitive trust, is it takes it from an infinite attack vector to a finite attack vector. What does that mean? That means the attacker will have to fly to your location, steal your device, and know how you unlock it before you find out that the device is gone. This makes it absolutely challenging for any attacker. And in fact, it makes it 3 times safer, which means
no password-based attacks, no credential phishing attacks, and no adversarial email attacks.
exactly. And that means, most importantly, you can prevent account takeover. But there are some other benefits. It is passwordless. It prevents ransomware. It stops lapses. And if you were at Infosec, you could have come to our booth. But since you're not, you can send us a message, and we are happy to talk to you further about protecting your business. I'm Al.
I'm Dennis. Thank you.
Thank you.